Greetings again. Today we are here with a topic of physiology, CVS, fast response action potential. So, what is the significance of fast response action potential? To know that, first let's see the types of cardiac cells. Cardiac cells are of two types: working and junctional. Working cells are only and only contractile, whereas junctional cells are the ones which initiate and conduct action potential. And fast response action potential takes place only and only in working myocardial cells. Now, what is this fast response action potential? It is the change in potential of the cell when these cells are excited and do what they are meant to, in this case contract only. So let's plot a graph. Suppose this be the y-axis, it denotes the potential, and the x-axis denote the time. So the RMP for such cells or the working cells is minus 90 millivolt. Let's plot 0 somewhere here and plus 35 here. So when the cell is in RMP, it is at around 90 millivolts. On being excited, the potential rises to plus 35 millivolts. Then it comes down, forms a plateau, and again falls down to the RMP or resting membrane potential of minus 90 millivolts. For ease of study, this graph has been divided into following parts: 0, 1, 2, and 3. So let's learn about the significance of each of these. In 0 there is a rapid sodium influx. There is rapid sodium influx. But there is a doubt. As we all know, sodium has a potential difference of around plus 65 millivolt. But as seen here, it only rises to around plus 35. So what are the reasons behind it? First of all, the sodium influx is regulated by voltage gated channels. Second, it also depends on the time for which these channels are open. And lastly, as sodium influx continues, the gradient is gradually disrupted, which hinders the entry of sodium. Let's move on to the next part, which is 1. So what happens in 1? In 1, nothing much, just potassium exits the cell, potassium efflux. This potassium efflux occurs to ensure the electrochemical gradient of the cell is maintained. Number two is due to potassium efflux, and calcium influx. In this stage, slow calcium channels open, which results in gradual entry of calcium into the cell. Stage 2 is also the reason of refractory period. Refractory period of heart. So what does this mean? It means that if within this period, even after the heart being excited by n number of neurons, won't show any action potential. That's the reason why heart muscles don't fatigue. And as is clearly visible, it forms a plateau. Coming forward is number 4. During number 4, calcium channels are closed, and the closure of calcium channels again leads to potassium efflux being the only driving force driving the change in potential of the cell. And after all this, the cell has again achieved its RMP, or resting membrane potential. But we forgot that for a normal cell, the gradient of potassium is concentration of potassium is high inside the cell, whereas sodium is high outside the cells. In order to maintain this gradient again, or in order to create this gradient again, there are several pumps called as sodium calcium pumps and sodium potassium pumps. Sodium calcium pump, this pumps sodium inside the cell and bringing out calcium outside, whereas sodium potassium pump, it pumps out sodium outside the cell and potassium inside the cell. After all this, the RMP is again achieved, and also the ionic gradient of the cell is again made. And as you saw, there was no need for any generation of impulse, because that's the function of junctional cells, and which will be studied in slow response fraction potential in oncoming videos. Thank you for now. Have a good day ahead.